All right, our topic for today is index laws for multiplication and division. Now, you will remember, I trust, that when we express a number like, let's say, 3 to the 4th, then we have two terms that we're talking about here. We call this number, the big 3, we call it the base. And the little number up here we call the index, or the exponent, or the power. All of those mean the same thing. The index, or the exponent, or the power. Indices is plural of index. Now, this form is called index notation. So if we use something that is a base raised to a power, we call that index notation. Now, also revision, I hope. Let's talk about what this index notation means. 3 to the 4th does not equal 3 times 4. It's not the same thing. What does this mean? It means 3 times 3 times 3 times 3. In other words, the 4 tells me that I multiply 3 by itself 4 times. I have 4 3's that I multiply by themselves. So 3 times 3 is 9, times 3 is 27, times 3 is 81. This is index notation, and this is called expanded form. So if you were to write, if you had a question that said, write this in expanded form, it's just wanting you to write that. Or if it said this, and it wants you to write it in index notation, then you just need to write it like that. And if it said evaluate, then we actually want a number at the end. 3 times 3 is 9, times 3 is 27, times 3 is 81. And that's just the evaluation. Now, what we're dealing with today, in particular, is some of the laws that we can use when we are dealing with index notation. So, we'll start with this example that I've already written up here. And let's say that we had 3 to the 4th, and we wanted to multiply that by 3 squared. Now, if you think about this, 3 to the 4th means 3 times 3 times 3 times 3, which we've already written up there, times 3 squared means 3 times 3. Now, if I wanted to simplify that, as you know, because of the associative law, I can take these brackets out altogether. They don't need to be there. And then what do I have? 3 times 3 times 3 times 3 times 3 times 3. Or in index notation, I could write that as 3 to the 6th. Now, you should recognize the pattern here, I hope, and that is 3 to the 4th times 3 squared. The bases are both the same. In order for this to work, the bases have to be the same. If the bases are the same, then what do I do with the exponents? I just add them together. So here's an example. Here's another example. Let's say that I had 5 to the 3rd times 5 to the 7th times 5 squared. Now, if I wanted to figure out what the actual answer was, to evaluate that, that would be much more difficult. But all I want to do is write this in simplified index notation. What do? 5 to the 3rd to the 7th and squared. I add 3 and 7, which is 10, that's right. And I add 2 to that, and that is 12, exactly. 5 to the 12th. And I'm done. Let's try another example. Make it a little easier. 5 cubed, or 5 to the 3rd, times 5 to the 4th equals, what am I going to do with my exponents? I'm going to add them together. 5 to the 3rd, 5 to the 4th gives me 5 to the 7th. One more example of this. We'll use 6 for a change. 6 to the 5th times 6 times 6 squared equals. Now we're missing something in this one that we have to remember, and that is if there's no exponent there, then what's the exponent assumed to be? Well, I've multiplied 6, but there's no more to multiply it by, so it's just 6 to the first. If I were to write an exponent there, it would be a 1. So I have 6 to the 5th times 6 to the 1st is 6 to the 6th, times 6 squared gives me 6 to the 8th. Now, that is the index law for multiplication. There's a similar one that works in a very similar way. Now, if we were to write this, by the way, as an actual law, the way we write it, using pronumerals to summarize this law, is that we say x to the n plus x to the m, notice that the base is the same, is equal to x to the m plus n. In other words, if those two are the same, if the bases are the same, then we can add the exponents together. Similarly, it would probably make sense, although it doesn't really matter, it would probably make sense if I put these in the same order, m plus n, m plus n, just to make it a little more clear. The same idea works with division. Let's say, for sake of discussion, that I had, and we'll make this a fairly simple one to start with, 4 to the 3rd divided by, I'll make it 4 to the 4th. 4 to the 4th divided by 4 squared equals, now we can rewrite that in expanded form. What would it look like in expanded form? We would have 4 times 4 times 4 times 4 divided by 4 times 4. Now, if we had that big expanded fraction, what could we do with it? Well, 4 divided by 4 is just 1. So in other words, these would cancel each other out, and these would cancel each other out. And what would I be left with at the end? I would just have 4 squared. Now, if you look back at this, you would realize that it's 4, not 4 plus 2, because we divided. Since it's divided by, it's 4 minus 2. So our rule with division, sorry, I wrote addition there, that should be times, x to the m divided by x to the n is equal to what? What would be the rule that we're trying to figure out here? It would be m minus n. So if my bases are the same, then I can subtract, and I'm dividing, then I subtract the exponents. Let's use some examples. Make sure we've got a good handle on this. Let's say that we start with 5 to the 7th divided by 5 cubed. Now, it's always easier, in my opinion, to write these as a fraction, though you don't have to do that. 5 to the 7th divided by 5 to the 3rd is equal to, and what do I do with the exponents? Because I'm dividing, I subtract, and I get 5 to the 4th. And that's all there is to it, I'm just subtracting. Let's try one slightly more difficult. How about this? 6 to the 20th divided by 6 to the 5th. This time I'm not going to write it as a fraction. What do we have to do with the exponents? All we have to do is subtract them. 20 take away 5 is 6 to the 15th. Now, I'm going to do one more example that will actually require us to do one more step, but I'm sure you can still handle it. Here we go. 10 times 5 excuse me, to the 6th divided by 4 times 5 squared. Now let's think about this for just a second. We have these numbers here at the beginning, and we can divide them. What do we get? 10 divided by 4. What's the common factor that I can divide out of both of those? The highest common factor. I can divide both of them by 2. And so I get 5 over 2. And then I have times. And what happens with my exponents whenever I divide them? Well, now it's 6 minus 2, so that's 5 to the 4th. And I have nothing left on the bottom because I divided that all out. I just have my 2 that's left over. But now notice I have 5 to the 4th times 5 on the top, so I can simplify that by doing what? by doing what we just did a little while ago and adding the exponents. There would be a 1 here, so my final answer would be 5 to the 5th over 2. And that is index laws for multiplication and division.